Okay, solving one-step inequalities. So the notes for today, solving one-step inequalities. So the first thing, what is an inequality? So an inequality is like an equation, except that instead of both sides being equal, one side is greater than the other. Good, Ben. So an inequality, you're going to be able to identify that because it will not have an equal sign. It'll have a greater than or less than sign. Now, there are going to be different types of inequalities, okay? The first one, in a strict inequality, the two sides cannot be, what do you think? In a strict inequality, the two sides cannot be greater or equal. So these two types of strict inequalities are what? What do you think they're called? Huh? You guys have already talked about them. We've already said their names.
Inequality?
Greater than and less than.
There we go. Greater than, less than.
I'm so excited for Halloween or October.
Shh, let's focus and then we
Yeah,
can talk
me and
about it.
Blake are going down to this cabin. And we're going to trick-or-treat.
Okay, so strict inequalities. They cannot be equal. Those type of strict inequalities are going to be greater than or less than.
I wonder what they're doing.
No idea. Because they're math. So in an inequality that is not strict, the two sides can also be equal. There we go. And what'd you say?
What?
What was
2 times Earth.
Greater than or equal to?
good?
Greater than or equal to?
So if I'm going to do greater than or equal to, what needs to go under this sign?
A line.
A line. Or less than or equal to. So the two types are, as you guys told me, greater than or equal to.
I gotta go to English next time. I hate English. So I gotta go to English next time.
Oh, shoot.
Okay. Key things that you need to remember. Okay? I would put this somewhere at the top of your paper, right below your paper. But you need to remember greater than and less than. When you go to graph them, it's going to be an open dot. Okay? Greater than or equal to. So greater than or equal to or less than or equal to. What kind of dot is it going to have when we graph? A closed dot.
I aced this part of the test.
So you got this part down.
The graphing, I got the...
Make sure you have that somewhere in your notes as a reminder of which is going to be an open dot versus a closed dot. Okay? So what if you did equal? What if you were graphing an equal sign? Yeah, a closed dot.
I'm going to cut my ears off.
Okay. So make sure...
Ears are popping.
Emily's like all over the place.
I
I'm
know.
gonna cut my ears off.
All right, here we go. That would be Van Gogh. Isn't that Van Gogh that cut his ear off? Yeah. All right, we ready?
I was watching an episode of Criminal Minds or somebody did that.
Okay. So, solving inequalities is like solving equations with a couple exceptions. The first exception, instead of an equal sign, we're going to use the inequality sign. We're going to talk about the next exception and a few example problems here. But let's go ahead and take a look at example number 1. So what I want us to do today is solve the inequality, and then we're going to graph it on the number line. So, again, it's just like solving an equation, so we're still going to circle our variable. We're still going to draw our line of equality, except for our line of equality this time is going to go through our inequality sign instead of our equal sign. Our goal is still to get the variable by itself. So we're going to use inverse operation, which would be
-5.
and golden rule, whatever I do to one side of the line of equality, I do to the other. I show that my 5's cancel. Now, this is where it's a little bit different. I bring my variable a down. Instead of bringing my equal sign down, I'm going to bring down my inequality sign. It stays the exact same way. When you add and subtract, that inequality sign will not flip. Okay? So I'm going to have a, how would I read that?
A is greater than 5.
Good. A is greater than 5. Again, if the symbol's wider part is facing the variable, that is greater than. Okay? So think, Pac-Man or alligator eats the bigger one. So A is greater than 5. So when we go to graph that on the number line, I'm not going to make you guys number like 0, 1, 2, 3, 4, 5, 6, 7, blah, blah. You don't need to do that. Because it's a greater than sign, is my dot going to be open or closed?
Close.
Okay, so I'm just going to label a 5 on here. What's my dot going to be?
Open.
Open.
Sorry.
Come on.
Sorry.
Okay, now which way would I draw my line? If A is greater than 5, is my line going to go this way?
Yes.
Or is my line going to go to the left?
Go right.
It's going to go to the right, showing that A is greater than 5.
I always just go the way that the smaller side of the arrow is pointing.
Oh. Yeah. So you're saying you look at your inequality sign like the arrow,
Yeah.
and that's the way it goes?
Yeah.
All right, we'll see if that's true. I've never looked at it that way. That's a really good mnemonic device to use.
That makes sense.
Yeah, it does. Now let's hope. Hopefully it's true now. Let's see.
'Cause it got me a on that.
What is it that? Oh, it's the multiplying and dividing, the flip one. Okay, do y'all have it?
Yeah.
Okay. Example number 2. Who can read this inequality to me?
B minus 3 is less than -5.
Very good. Okay. Chance, go ahead and finish this for me. Go ahead and get the variable by itself and solve. Out loud so I can hear you.
Solve it first.
Wait.
Yes.
How do you do
Well, when you add and subtract, you don't have to worry about flipping the sign at all. Okay, so to get the b by itself, what do I do?
You add 3 on both sides,
Okay.
and then you bring down your b and your less than sign,
Okay, so b is less than
-2.
-2. Remember, adding and subtracting, I don't change my inequality sign. I just bring it on down. So how we're going to graph that, we're going to come down here, find your number line, pick any spot, and you're going to put a number, -2. Now, if you really want to put your 0, -1, -2, -3, -4, -5, 1, 2, 3, 4, 5, you can do that. I didn't. I feel like you guys should be pretty good with number lines at this point. So if B is less than -2, which way should my arrow be going? If it's going to go to the left because it's less than. Now, greater than, less than sign, open dot or closed dot. So it's going to be an open dot, and you guys already told me my line is going to go to the left with my arrow.
No, I have.
So now look. Remember what Chance told us on example number 1? The arrowheads and the inequality sign are in fact pointing the same way. Ben, you had a question?
Oh, I was gonna say, so if it's like a line underneath it or greater than or equal to, does it point in the same direction or the opposite direction?
That's a good question, and why don't we find that answer to that question when we get to one of
Are
those?
you right?
All right, we ready? Let's take a look at example number 3. Okay. So we have, Dylan, can you read this one to me?
Alright, I think I got this one too. I think I got it.
35 is greater than or equal to 7.
Perfect. Yep. So again, circle my variable, draw my line of equality through my inequality sign. My goal is still to get the variable by itself. So the inverse operation of multiplication is what, Hannah?
Divide.
Oh, you got it. Divide.
Sorry.
It's all right. You made an on-task comment. I'm happy. All right, what do I bring down on my right side?
C.
Okay, so C is less than or equal to 5. Now, I want my variable on my left side. Okay? So we're just going to bring my C. Now, this is where it kind of gets confusing. You're going to have to flip that because the greater than needs to be at the 5. So you want this value to stay true, right? So right now it's saying 5 is greater than or less than C. C is less than or greater than 5. It means the same thing here. Okay? So on our number graph here, we come down. Open dot or closed dot?
Closed.
Closed. So we're going to make sure that's closed. We're going to put a 5. And which way does my arrow go here? C is less than or equal to 5. Left. That is correct. Good. What if I just said C is equal to 5? How would I graph that?
Closed.
I just put a closed dot on 5 and that'd be it, right? Yeah, that's it. If it's equal to, you just make a closed dot on the number that it's equal to and no line. Question so far? Doing all right? Okay. Let's take a look at example number 4. Who wants to read this one to me?
Me.
All right, Emily?
12 is greater. No. Yeah, 12 is greater than.
Wait. Is 12 getting eaten by Pac-Man?
No.
Okay.
12 is less than or equal to 3 is D.
Perfect.
Sorry.
All right, get the D by itself.
You divide
By?
3.
Okay. So my 3's cancel. What do I bring down on my left side?
D.
You mean on my right side?
That's on your right side. Left side's on.
So I'm going to bring down my inequality sign the same way, and then I'm going to take 12 divided by 3 and get... Okay, now, I want my variable on the left. So I'm going to bring my variable on the left. If I'm switching my variable to the left side, what happens to my inequality sign? It flips around, right?
Oh shoot. Oh my god.
So basically, you just want to make sure that if the greater than is facing the D, that when you bring it down, it's still greater than is facing the D. Okay? Open dot or closed dot? So I'm going to put a closed dot. I'm going to label it the number 4. Now, D is greater than or equal to 4, so which way is my line going to go?
The right.
So far, Chance's theory has proved right. Correct. Any questions so far? Do you guys feel like, okay, we've done this, it's been review.
Yes.
We did this last year. Good deal.
I did this last year.
Good job. I know Hannah did this last year because I saw one of her quizzes in the file cabinet that had this on it. Hannah Oakley, your quizzes and tests. I have them all.
We have
All right.
quizzes and tests.
Yep.
Do you have mine?
Yep, all of you guys. If you had Mr. Rikers last year, I have them from your Algebra 1A class.
Why am I saying Rikers?
Ricker, I don't know how to say his name.
Ricker.
Ricker. I don't know. Rickers.
I have.
Okay.
I had Algebra 1B last year, so.
Oh, yeah. I probably have some of those old ones, too. Okay, solving one-step inequalities.
Can I just not do them then?
No.
This is my old quiz.
Solving inequalities is like solving equations with a couple of exceptions.
I like C's on.
Exception 1, we already talked about on the previous page. Instead of using an equal sign, we use the inequality sign. Exception number 2, this is what you're going to write on your paper. When multiplying and dividing by a negative, what do you do with the inequality? So when you multiply or divide by a negative number, you're going to do what? Flip the inequality sign. Now, it's only when you multiply or divide by a negative number. That's the biggest thing you have to remember. You don't when you add or subtract by a negative number. Only when you multiply and divide by a negative number. I know you're like, Miss Lydic, I know you said this like 10 times in a row.
Your eye.
Sorry.
What? Harassing you on your left?
Does that make you feel better?
Yeah.
All right.
No, because it's under the.
Oh, you guys, just stop it. Just wait until I grade your papers. I'm going to like butcher them. Okay, example number 5.
The P. Oh yeah, you see that 5? It's not right. Is that?
All right, we're going to start. Circle our variable, draw our line of equality. Now, right here, what number am I dividing by? A -2. Because I am doing the inverse operation of multiplying by a -2 and dividing by a -2, I'm going to make sure that when I bring my variable down, the next thing I do is I flip my inequality sign. Okay? And then what's 10 divided by -2? -5. So because the number touching the variable and multiplying or dividing by a negative, I flip that inequality sign. I graph it the exact same way. How would I read this answer, though?
Is greater than negative.
Is Pac-Man eating E?
No.
No, so E is -5. So,
I thought it was like if Pac-Man eats the -5, then eats negative.
okay, so open or closed?
Open.
And which way should my line go? To the left. To the left,
I love that song.
her and I have a love-hate. Sometimes I love her stuff, and other times I'm like, eh.
Most of the time I hate it. If I'm being honest. I like the old 2000s.
Yes. All right, example number 6. So I have 2f is greater than -10. Pay attention to this one. How do I get the f by itself?
Divide by 2.
I'm dividing by 2. It's a positive number, right? So because I'm dividing by a positive number, do I flip my inequality sign?
No.
No. Even though that on the right side is a -10, that negative on the right has nothing to do with our determination if we flip that inequality sign. So I'm going to bring down my f. My inequality sign stays the same, so it's f is what?
F is -5.
Greater than -5. Open or close dot? Open. Which way does my line go? Which way does my line go? To the right, because f is bigger than that -5. So we have to show that the f is to the right of the -5 on the number line. But we don't know what f is. We just know that it's bigger. All right. Example number 7. If I'm going too fast and you're not getting them down, tell me. But otherwise, I think you guys are keeping pace, so we're going to keep going. G divided by -3 is what?
Is less than or equal to 10.
Good.
You still sick?
How do I get the variable by itself?
Times the 3.
Whoa. Times it by what?
-3 times 10.
Okay, so I'm multiplying by -3. Because I'm multiplying by -3, here's my exception. Exception number 2. I'm multiplying by a negative number. What happens to my inequality sign? It flips. And then what's 10 times -3? So my answer here is G is greater than or equal to -30. So my number line, aren't you guys glad you don't have to number from 0 to 30?
Yeah.
Open or closed?
Close.
I'll just take the 0 on that one.
Put my -30. Okay, if G is greater than or equal to -30, which way does my line go?
To the right.
Whichever way the arrows point.
Things change.
I know, I really like that. I've never noticed that before. And I'm not going to lie, at my previous school, the last 2 years, we skipped this lesson. We didn't do inequalities.
Wish we could just do that.
But
No.
then we would,
Then we wouldn't have learned something new today from you.
and we would have to do hard stuff.
We're going to do hard stuff next week.
God.
Remember, when you get back to school, initially when you come back to school, we start with a little bit of review. Kind of get your minds working again. After we do that little bit of review, we start the new hard stuff. Okay, how do I get the h by itself? How do I get the h by itself? By? It's a positive 5, right?
Yep.
So when I go to rewrite it, I flip my sign. Do I?
No.
No, why not?
Because it's not, it's a positive.
It's a positive. I'm dividing by a positive number. So my sign, my inequality sign, stays the same. Ooh, goodness gracious, what do I do here? Negative 8 divided by 5. If I do that, I'm going to get a what?
A decimal.
A decimal. I do not want answers in decimal form. So we're going to leave it as a fraction. But if we leave a number as a fraction, we have to make sure we put it in what form? Simplest form. It's negative, and I want it left as an improper fraction. What's an improper fraction?
Where a bigger numbers are positive.
Okay, so don't make it as a mixed number. Leave it as an improper fraction. So negative 8 over 5, can you reduce that?
No.
No, so what's my final answer? Negative 8 over 5. You guys should be happy I'm not making you label this on the number line now. Open dot or closed dot?
Oh, closed.
And that's going to be negative 8/5. And H is what? To the left because it's, H is what?
Less than.
Or equal to negative 8/5. All right, 2 more. Yeah. I make this promise to you now. I will never give you a set of notes and not give you a homework worksheet that goes with it. You didn't like that promise? Sorry, but that's a promise I promise to keep. When I promise, that really means it's true.
What if I really promise not to do anything?
Okay,
I could do that.
I believe you, since why you're sitting right here again.
Yep.
Okay,
Yeah.
how do I get the I by itself?
Actually, just because I didn't turn it on.
How do I get the I by itself?
You gotta divide by negative 4.
Okay, so when I go to divide by negative 4, what do I do to my inequality sign? I'm going to flip it because I'm dividing by a negative number. So I have negative 12 divided by negative 4 gets me a
Negative. It's
positive 3, good. Now, this is the problem. I got to flip it again. So I put my I, make sure that it's showing that it's greater than or equal to, so the I is greater than or equal to 3. Open or closed dot on my number line? Closed. Positive 3. Which way is my line going to go? To the right, because I is greater than or equal to. All right, example number 10. Last one. Okay. How do I get the J by itself, you guys? Ooh. Take a look. So I have negative 3 is less than J minus 3. Add what?
3.
So if I'm just adding 3, do I flip my sign?
No.
No, my sign stays the same. So J is greater than negative 3 plus 3, 0. And what do I do with my sign here?
Keep it.
I keep it. But what do I need to do with my variable?
Flip it.
Flip it. So what happens when I move my variable to the left?
Your sign comes with it.
Okay, so J is greater than 0. Open or closed?
Ow, I hurt really bad.
Open or closed? Left or right?
Do not.
How about to the right? Because J is greater than 0.
Do not do that. So I didn't do it.